Hello, we are continuing in section 3.4 and we're talking about quadratic equations in intercept form. All right, let's try problem number 4. Graph the parabola f of x equals negative 2x times x plus 3. All right, we're going to find these different parts of the parabola first, and then we'll use those points to be able to graph them. So finding x-intercepts, we're going to let y equal 0 and then solve for x. So 0 equals negative 2x times x plus 3. So let's put both of those factors equal to 0 using the zero product property, and we'll solve them. So here if I divide by negative 2, 0 divided by negative 2 is still 0. And here when I subtract 3 over, I get x equals negative 3. But then let's make sure that we write our x-intercepts as points. So when x is 0, y is also 0. Remember we put 0 in place of y. When x is negative 3, our y was 0. So there are our two x-intercepts. All right, let's go find the y-intercept now. So for y-intercept, we're going to let x be 0 and solve for y. So y equals negative 2. In place of x, I'm going to put 0, and then times 0 plus 3. Let's simplify this. Negative 2 times 0 is just 0. And 0 plus 3 is 3. So 0 times 3 is just 0. So again, we have a y-intercept that is 0, 0. Now let's find the line of symmetry. So remember, our line of symmetry is halfway in between our two x-intercepts that we have here. So we'll have x equals, one of our x values was 0, plus our other x value, which is negative 3, and then divide it by 2, because we're finding the average, the middle, exactly halfway between these, so the average of them. So x equals negative 3 over 2, or if we change that to a fraction, we can say that's negative 1.5. So let's just call it x equals negative 1.5. Great. Next we need to find the vertex. And remember, we're using this x as our x-coordinate of our vertex. So I've got my x is negative 1.5, and now I need to go and find what my y is. So y equals, and let's substitute it back into the equation, the original equation there, negative 2 times negative 1.5, and then times x, which is our negative 1.5, plus 3. Let's combine these together. So negative 2 times negative 1.5 is going to be 3, and then negative 1.5 plus 3 is 1.5. And then if I multiply those together, I get y equals 4.5. All right, so there is my vertex. So now I've got all of these different points and the line of symmetry. Let's go ahead and graph these now. All right, there is our graph. So when we plot the points, connect those dots together, and then draw our axis of symmetry, we have this graph. Now notice it's an upside down parabola, and it makes sense that it's an upside down parabola because our leading term there, right, that a is a negative number. So just like we talked about before, how the a, when it's in vertex form, makes that parabola flip upside down, it does the same thing here. So let's go ahead and state whether this is a maximum or a minimum. Again, this is the highest point of the graph, So we're going to have a maximum at the vertex, and that point is negative 1.5, comma 4.5. All right, let's take a look at the next one. So on problem 5, we've got this function, g of x equals x squared plus 5x plus 6. So let's first find our y-intercept. So remember, when we're finding our y-intercept, we let x be 0 and solve for y. So I'm going to have y, which is the same as that g of x, equals, and then in place of my x's, I'm going to put 0. So 0 squared plus 5 times 0 plus 6. Well, 0 squared is just 0. 5 times 0 is 0. And so all we have left there is 6. So y equals 6. So my y-intercept, when x is 0, y is 6. All right, what about our x-intercepts? Well, we got something a little bit different going on here. In the previous ones, we had all of these that were in this intercept form, and so we could set those two factors equal to 0 and solve them. However, this is not in that form, so it looks like we might need something else to help us find these x-intercepts. So how could we write this equation in intercept form? Or can we write it that way? If we were trying to find the vertex next, we learned that that vertex is exactly halfway in between our two x-intercepts, but we don't know what those x-intercepts are, so that's going to be hard for us to find that, as well as our axis of symmetry if we don't know what that vertex is. So it looks like we're going to need to have something else here to help us do this. So remember I said at the beginning, intercept form is sometimes called factored form, and that's because we're going to take this polynomial, change it into factored form, and then we'll be able to find our x-intercepts a lot easier. So in the next section, we'll talk about factoring, and then we'll go through and find out how we can use it on equations that look like this. Have a wonderful day.